What is an API? API stands for Application Programming Interface. Think of it as a bridge that allows different applications to communicate with each other. For example, when you book a flight online, the travel website isn't storing all the flight data itself. Instead, it requires the flight details from the airline's API, which sends back the relevant data. This interaction happens in milliseconds. There are different types of APIs, but today we are focusing on REST APIs, the most commonly used in modern web applications. What means REST? Representational State Transfer. It is a set of architectural principles that define how web services communicate. RESTful APIs follow certain rules to ensure that they are scalable and easy to use. REST principles. Statelessness. Each request from a client to a server must contain all the necessary information. The server does not store any client session. Client-server architecture. The client and server operate independently, allowing the flexibility in development. Cacheability. Responses can be cached to improve performance and reduce server loads. Layered systems. The API can be structured in multiple layers for better security and scalability. Uniform interface. The API must follow a consistent and predictable structure. In a REST API, the resources are represented by URLs, also known as endpoints. These endpoints interact using HTTP methods. Get HTTP method. Retrieve existing data like a list of available books from a library. Post HTTP method. Create a new data. This is also an example call made from Postman. We can see the response JSON and 200 HTTP code. This is the status code. That means the API responded successfully and a new item with ID 1, name Apple, and a new price was saved. That method is used for existing data. This is another HTTP method used for updating the existing data. The product with ID 1 will have the new name mobile, a new price, and a new quantity. When that method was called, the HTTP status code was 200, so the product details were successfully updated. Delete is another HTTP method, and it's used for removing data. In the example, the URL contains a query parameter, the item ID to be deleted. So the item with ID 1 was deleted successfully, as we can see from the status code. For example, an API endpoint for fetching a user's details might look like this. The API responds with requested user data in JSON format, which is the commonly used format for REST APIs, making a REST API request. Let's see how a REST API works in action. Imagine you are testing an e-commerce API that retrieves products details. You will send a GET request like this. The server will respond with something like this. An object with fields ID, name, price in stock. So the user will see only the values for these fields. The response should respect the contract between services. ID should be integer, name is string, price is double, in stock is a boolean. If the response will be changed without informing the consumer, it may generate issues because this is not a part from the agreed contract. And this is an example. Product ID is not anymore an integer. In this example, it's a string. So it's another data type that can generate an internal server error. So let's keep in mind that responses and requests between two components that communicate through APIs need to respect contracts to avoid issues and bad requests. To interact with API like this, we often use tools like Postman. Postman allows us to send API requests, inspect responses, and debug issues. In Postman, you will find all HTTP methods you need for testing. So let's see some best practices. Testing APIs is essential to ensure they function as expected. Check response codes. Every API response should return an appropriate HTTP status code. For example, 200 OK means success, while 400 indicates a missing resource, even unauthorized. Validate data structure. Ensure that your APIs returns the correct data format and types. Handle error responses. APIs should provide meaningful error messages. Security measures. Always verify authentication and authorization, especially when you're dealing with sensitive data.